Good afternoon and welcome back once again. Next up, we've again got Phil Reinbold, this time discussing the pre-purchase inspection of a PT6 engine. Enjoy.
Thank you. Good afternoon, everybody. I'll start out saying I've even got some North Dakota family members up there that I have forced to watch this presentation. So a shout out to Larry Mueller up there. I feel for him. He's going to have to endure one more here. What I want to say is this presentation, if you just watch the J18 presentation, some of this material is similar and common to any turbine engine. So please pardon me if some of this is duplicated, but it's still applicable. So if you have any questions at any time, please sing out, interrupt the presentation. I don't have any problem at all with answering your questions. So the crux of this presentation is as IAs, we get a variety of aircraft in the shop that we're responsible for. More and more turbine airplanes are funneling in, whether they're corporate or ag or private owners or whatever it is, that we're becoming more and more responsible for. So if you don't presently deal with a PT6 powered airplane, likely you will. And this presentation here is directed against the situation where your owner, operator, friend, whatever, has got a out in Southern California, he's got a King Air or a Cheyenne that is priced, he just can't resist it. Or in the ag world, same thing. There's an engine that a guy's ready to purchase to put in his airframe, and the price is so great that they're just going to buy it sight unseen. You, as the director of maintenance, will inherit this mess. And what I'd like to do is make it as painless for you as possible. Please do not let these guys purchase an airplane, no matter how good it looks, without doing an adequate pre-purchase. When you get into turbine equipment, it can be horrendously expensive. And I'm in the engine side of things, so yes, I do enjoy doing nice engine jobs. What I don't enjoy is when an engine purchase or an aircraft purchase ends up putting a flight department out of business, ends up costing somebody their job, or a lot of screaming and finger pointing and all that type of stuff, when it would be a lot easier to discover this stuff before you sign the check. The PT6, as everybody knows, is an incredibly reliable, incredibly durable engine on a lot of different airframes and a lot of different versions of it. So I won't get too much into the mechanics of it. If you're looking at this picture here, you can see some of the common items that you'll see in virtually every configuration. They'll look a little different. Some will be located in different areas, but this is basically what you're looking at. So here's the King Air, the Cheyenne, that your owner is just chomping at the bit to buy. And he's going to send you down there to look at it, or it's going to arrive in your shop, and you're going to be responsible for making sure that he gets a smoking deal. If you don't have a lot of experience on the King Air or the Cheyenne, or whatever it is that he's considering purchasing, hire somebody that does have the experience and will get you an excellent report concerning the conditions of the engines. At least the engines are probably the most expensive component on the airplane, maybe neck and neck, or maybe even second to some of these avionics packages. But certainly in most airplanes, the turbine engine is far and away the most expensive component, especially if you have two of them. So you get the airplane in the shop, and you generally look over the airframe and the engines. There's a couple of things similar to what I said in the JT15 presentation. If the airframe's a beater, if it's heavily corroded, if it's been abused, If it's, if you're seeing other things, if you see corrosion, that type of thing, you're going to be dealing with the same issues in the engine. So spend some time looking at the condition of the airframe for a hard landing, for corrosion, for erosion, for lightning strike. Make sure you spend some time looking at the bonding straps, the trailing edges of surfaces, anything that could show that the aircraft had been struck by lightning that was unreported. But just general condition. And I know you do that anyway, just kind of an extra reminder. Figure out where the aircraft came from. Did it operate out of a smoke belching city? Did it operate in a coastal environment? Has it been sitting for a long period of time without being operated? Things like that, all good indications that you need to do more investigation, or like some of the other stuff I'm going to bring up, it has to be factored into the price of the aircraft before you sign the check. You will probably end up being the hero out of this whole thing, and certainly make it easier for yourself later if you catch this stuff now. So you've already looked over the airplane. You've determined generally what you're looking at, what you might be looking at when you uncowl the engine. And so you start by uncowling the engine. You look at the cases, the inlet case, the exhaust case, the accessory cases for corrosion, for any kind of heavy deposit, that type of thing, for general condition. We'll just very briefly go through this, what makes the PT6 such a durable, such a resilient engine. It's a reverse flow engine. The air, if you look at the right side in the cold section there with the blue, the air enters the engine through the inlet screen. It has to turn the corner, even more of a corner if the ice doors are deflected, to make sure that any kind of rocks and dirt and all that type of stuff, when they're deflected, it also helps deflect any kind of ice or moisture from going through the compressor. As you can see, it goes from kind of a light green to a dark blue there. It goes through several stages of compression. And it enters, if you go to the dark blue area there, it enters into the combustion line or the burner can. Up at the very top there in the yellow, you can see a fuel nozzle sticking down. The igniters ignite the fuel mixture. It goes through the combustion liner or burner can there and goes through several stages of turbine. Goes first through the compressor turbine, then through one or more stages of power turbine. And you can see it's turning orange to red there, and out the stacks it goes. So that's the general airflow in the engine. It's very durable. This engine can keep beating like few pieces of equipment I've ever seen, and it continues to perform. I'm a big Pratt Whitney fan, and I've worked on them since about 1980. So I've spent a lot of time sliding around under one of these cowlings. One of the first things you're going to want to do, I used to do a lot of this. I used to do a lot of jet calibration on aircraft, is make sure that your gauges are accurate. Nobody's going to try to pawn something off on you that is not right or is not fair, right? They're going to be perfectly honest with you. Well, I tell you what, let's just make sure that we add to the honesty by verifying that what we're seeing on the panel is actually what those engines are generating. Here's an indication of a jet cal. Used to do a lot of that. It's harder and harder to find actual jet cal equipment that's been done. If it's been done, that's a positive. So if you have the ability to do that before you do your engine runs. If you don't have the ability to do a full jet cal, then at the very least on a PT6, gain access to and use, it's called a bar field, where you do your torque calibration, calibrate the torque. It's that little device right down there in the bottom left-hand corner. It's a very simple thing. At the very least, check the adjustment points. If you have the time to go through the whole torque cal chart, do it, document it, so that you know that your indications are accurate, and you can also log that a torque calibration was done. Also, on a PT6, the second phase of this is if there is no jet cal available, do an ITT calibration. Again, if you don't have time to do the whole calibration, at the very least, check the adjustment points. That's when the tolerance, in those specific spots, the tolerance is the absolute minimum. So it's better if you do the whole chart, where you can see, you know, what it does at the high end, what it does at the low end, both on torque and ITT. But do check your gauges. That's going to be very important when we run the engine. These boxes, sometimes you can borrow them. Sometimes the operator on the field has them. He may or may not let you borrow them. You may have to pay to get this done. It's worth it. Again, what I'll preface this whole thing about is, if you don't have the experience to do these checks, then either contact an engine repair agency, contact an FBO, contact somebody that you know and trust. Don't let this guy purchase this airplane without going through these steps. The cost on something like this might be $3,000 to $5,000 to $8,000 or more. It is worth it if it saves you from buying something that turns out to be a boat anchor, or turns out to end up shutting the lights off in the hangar and everybody go home because the flight operation is bankrupt. So a little bit of investment, even if you choose not to purchase the airplane, it is worth it in spades. Make sure that your operator, make sure you insist to your operator, you want this thing checked over before he writes a check. So there's the ITT calibration. Here's just a brief view of the ITT, a typical ITT system. This is a 40 to 60 series engine that looks different on the smaller engines, but basically you're checking that the ITT system is putting out what the engine is generating. There's trimmer probes, and there's other things that you check, system resistance and that type of thing. It's a simple process, and it's worth making sure that you do it. Now, a bore scope inspection mandatory, or some type of inspection. Some people will even split the engine before they purchase it. You may run into some issues with this. The guy doesn't want you to scope it, or they're trying to throw obstacles to you bore scoping it. If you want to know more about that, please feel free to give me a call. I can discuss that with you. But the bottom line is, you're going to be spending a lot of money on this machine, and you want, in your mind, the operator's mind, and certainly the beam counter's mind at your own place, you want to know exactly what you're facing. So the bore scope, a guy comes out to a bore scope, or you do it yourself if you have the ability. The bore scope, this particular one here is just a guy that, and I've done many of these too, that he's just looking through the scope with his eye. There's a lot of scopes out these days that accurately and beautifully record pictures of exactly what you're seeing, and they put it in a fabulous report with times and cycles and actual condition, position on the engine that they saw this or that condition. It's well worth it to have this report in your hand. Basically, on the PT6, what you're going to do is pull the fuel nozzles. At the very least, pull 4 fuel nozzles. I recommend you pull them all, because the hole you don't look in is the hole that likely something is hiding. But what I usually do, if they won't let you pull all the nozzles, is pull the one at the 10 o'clock, the 10 o'clock, 2 o'clock, 5 o'clock and maybe the 7 or 8 o'clock fuel nozzle. And there's some flexibility. You can see more through those holes. If you have the opportunity to pull all the nozzles, try to do it. And here's a depiction of what it is that you're looking at. You see the borescope tube right at the top of the engine there. It's got a little knob that affixes it in the engine so it doesn't move around. And it snakes around the outer portion of the combustion liner there. And it ends up looking, if you see this, the black arrow there, it comes out and it looks right at the hottest part of the engine, the most susceptible to damage. And that's the compressor turbine guide vane that you're looking at right there. And it also looks at the compressor turbine wheel, which you can see right there. So since that's the hottest by far part of the engine, that's where likely you'll have most of the abuse, most of the damage, and certainly most of the expense. So that's what we're looking at. That's what we're looking for in the hot section. We're also going to be looking at the cold section. Let's see if I got a picture. Yes, there you go. We're going to be looking at the compressor. Is the compressor filthy? Is it corroded? Does it have foreign object damage like this one? Not all damage is a big deal. Maybe it can be blended out. Maybe it can't. Lightning strike and FOD very likely are covered by insurance. That's why we have insurance. It's important that this is documented, again, before you sign the check, so that the guy that's selling the airplane pays for it and not you, either in terms of paying the bill or higher insurance premiums. If this was done before you inherited the airplane or the engine, if you're just buying the engine, have the guy that's selling it pay for this damage, or work it into the price of the deal. At the very least, be aware of it. And there's some of our culprits right there: tie wraps and safety wire and washers. And on the previous presentation, we had a guy that was working on the airplane, sucked one of his gloves off, and it went completely through the engine, didn't cause a bit of damage. But when soft things go through engines, sometimes they plug up orifices or cooling passages, that type of thing. So it's good to know. It's good to know what you may be inheriting. So as you go through the borescope here, this part is physically removed. There's the compressor turbine guide vane. Its function is to guide the gas against the turbine wheel at the proper angle and at the proper velocity, so that it gets the maximum efficiency out of the engine. You're going to find, and we'll show this later, you're going to find holes, you're going to find cracks, you're going to find dents, that type of stuff. A lot of this damage is acceptable and serviceable. If you have a guy that knows what he's looking at, then he'll be able to probably tell you what's acceptable and what's not. When you're looking through a borescope, sometimes acceptable damage looks like the Grand Canyon. Other times, stuff that doesn't look like it's that big of a deal could be major. You might have a nick right at the base of a blade. That is not repairable. You might have several cracks in this vane ring right here. They're not converging. A piece is not going to come out. Perfectly acceptable. But again, that's based on experience and letting you know the condition of the engine that you're getting. Now, this isn't acceptable in anybody's world. Here's a vane that has been burned up because of a streaking fuel nozzle. So we discovered this up front. Either we walk from the airplane or the engine, or we factor not only this vane ring change, this will be a boat anchor, this will not go any further, or, not only will we factor this into the negotiation, this vane ring has to be changed, and all the blades that were in this compressor turbine wheel will also have to be changed. So you could be looking at you might be looking as high as $150,000 for this repair. A good thing that you don't have to pay for this because you discovered it. You would, in general, you might likely see this in the performance of the engine. But again, it's important that we've identified that the performance that we're seeing is actually what we're getting, that the gauges haven't been dialed to cover up certain conditions. This particular condition here is also, who knows how far away from a total engine failure, as you can imagine. So good to discover high dollar repairs before they come out of your pocket. And here's our compressor turbine wheel. This is, again, the hottest part of the engine. The gas comes out of that vane ring. It impinges on this compressor turbine wheel, and this part here drives the entire compressor. This component right here. You can see outside. You can see the combustion liner. Or the burner can. You can see the fuel nozzles going through from the outer case into the combustion liner. A borescope also will assess the condition of the inside of the burner can, the outer exit duct, and the combustion liner itself for any kind of damage or anything that could cost you money. Here's an example of another thing that is good to discover sooner than later. Leading edge erosion on the compressor turbine blades. In the combustion line itself, what happens, depending on how the parts fit together, sometimes if they don't fit together correctly, it'll develop towers of carbon. And those little towers are fragile, they break off, and that fine carbon goes through onto the turbine wheel, and it erodes the leading edge of these blades. You can fix them up to a certain point if you catch it soon enough, if you're aware of it. If your pilot's been squawking that he thinks he's seen little bits of smoke coming out of the stack periodically, a good indication you got carbon erosion going on. This is something that if you discover it, you might be able to go back to whoever overhauled it or hot sectioned it and say, hey, the fit is not right. I'm getting erosion on these blades. If you let it go too far, one, you'll end up paying for it. Two, the blades won't be repairable. So if you catch it soon enough, radius the leading edge of these blades, and they're still serviceable. You can save a set of blades. So a good thing to discover as part of your pre-purchase inspection. Sulfidation. If the aircraft has been operated in a coastal area or they have poor compressor washing procedures, again, you can catch this soon enough. You can stop it before it starts chewing away past the coating and into the parent material, like you can see here. These blades are headed to the junk bin, that they've gone too far. Sometimes you can catch the sulfidation. It can be mechanically removed, and you can save a whole set of blades, and you can save yourself a lot of expense. This will be discovered on the borescope as well. Obviously, you're going to check the oil system, you're going to check the filters, you're going to check the chip detectors see if the thing's generating metal. And that's something you want to catch up front sooner than later as an indication of what kind of problems might surface later. Several finger screens in a PT6, finger screens, oil filters, chip detectors. If you have the time, if they'll permit you, check them all. If the operator, let's say you've run across a very quality operator that's not only doing trend monitoring, but also doing oil analysis, you'll find those records in the aircraft and the engine paperwork, an indication the engine's probably had some good care, that it's a conscientious operator, and it'll show any kind of, let me go to the next picture here. There you go. You'll get reports from the oil analysis lab. What you're seeing most of the time, you'll find, no fouls, no errors, nothing. But if you did have a problem or a certain element is creeping up, it would be good for you to know what the trend is on the oil analysis. Sometimes oil analysis services are paired with trend monitoring. It's a good double whammy to make sure that you're aware of what might creep up in terms of maintenance and certainly engine condition. If you see, again, lightning strike on any part of the airplane, the operator truly, I mean, being honest, the guy might not have known that he was struck by lightning. If you see it on the airframe, there's a really good chance it's gone through the engine. This is an expensive repair, and many times a lightning strike will cause a bearing failure. You can see where the lightning's tracked across this roller bearing here. Oftentimes, if it's not soon enough, this results in this. So it's expensive and it's a potential problem with flight safety. If something's going to let go, it's going to do it at the worst possible time. So something good to discover when you're looking at the airframe for this type of defect. As you're doing your paperwork research on this engine or these two engines, there's two bulletins. Usually in the Pratt Whitney world, it's bulletin 02 or 03 of each series. And it will cover the rotating group and the cycle limitations for all of those components that are in that engine. Make sure you spend some time looking at your logbooks to see what's installed in your engine and how many cycles are remaining. And this is the chart here that'll show you exactly, based on part number, what the cycle limitations are for that specific component. Most of the time, most shops, certainly all the five-star shops, will not short build an engine. Now, I don't want to mislead you. It's an operator's engine. If he tells you that that's the way he wants that engine built, then technically you have no choice. For the most part, shops will build an engine so that it doesn't have to be disassembled until the next major access to that part. Sometimes that doesn't happen, either to save money, the guy's unscrupulous, he figures you'll be able to get to it the next time you do hot section or something like that. Just be aware. Do a quality job of researching this to make sure you're not inheriting a lead weight around your neck. These parts are extremely expensive, in the tens of thousands of dollars. And a little bit of time spent here, again, can be factored into the negotiation and guaranteed it'll make you a hero for saving countless thousands of dollars for your operation. So here, for instance, on this engine right here, this particular engine serial number 123, here's the condition of his rotating group. You can see that it's 1,800 hours time since new, and he's got 1,300 cycles that he's used up on the various components. He's got, almost 19,000 cycles remaining. You go down to the CT disc, he's only got 9,000 cycles remaining. Still, that's a lot of time. You don't want to be caught with something that's got 800 cycles remaining or 1,000 cycles remaining, and you're not aware of it, especially if it's deep within the engine. Again, something that needs to be factored into the purchase price. Okay, just a quick review. Make sure the guy does a good job. Whoever's trying to sell you this has done a good job of documentation. Proper sign-offs, hot sections, bulletin compliance, tags, endorsements, that type of stuff, so that you don't end up having to go to recomply with an inspection that was done but wasn't really signed off. Believe me, 10, 15 years later, you're not going to be able to find the documentation. And you're going to have to spend the money to get it recomplied with. And then you get into it and you find that it's already been done, but you can't trace it, that type of thing. We already talked about short cycle stuff. Make sure you're not in a problem there. PT6s, you're going to run into more and more PMA parts. in the ag world, in the corporate world, that type of thing. Parts, many of us are aware that some of those parts may be even superior to manufacturer. That's not the point. The point is, if one of those parts fails, if there's any downstream damage, you will get no manufacturer support at all. If a Pratt part fails, there's a possibility that the manufacturer may help you in the repair of it. And I'm not casting any stones on PMA parts. Some of them are absolutely excellent. Just be aware that it's a factor you'll have to consider in the cost and operation of the engine. There may be warranty considerations. If you, even the 5-star shops can install PMA, but you have to sign a waiver that you know that those parts are installed and that you've taken responsibility for them. This is a big one, this next one, lack of proper preservation. If you're buying an airplane that's been sitting around for 6 months, a year, 2 years, make sure that the guy has been running the engines regularly or that it's been preserved properly. Because if there's no record, if there's no documentation of that, you must do a lack of proper preservation inspection. And what that involves is every fluid wetted area in the engine. That's oil and fuel. And you can give a little bit of thought to that. You can see how deep in the engine you'd have to go to complete that inspection. It's expensive and it's not necessary. It's a waste of money. I hate getting these jobs into the shop because it means that an operator is at the end of this work, he's going to be no better off than he was before, and he's going to have written a good sized check to have it complied with. So if you're purchasing, make sure there's a log or some record believe that you trust that the aircraft's been run regularly. TBO, hot section extensions, if a guy is on an extended TBO program or a hot section extension because of trend monitoring, be aware that those extensions will very likely not transfer to you. Now, some may transfer if you're on a power by the hour program, or if you're on some programs that permit you to pick up where they left off in terms of maintenance and tooling and that type of stuff. Just be aware that it's a factor. The guy represents it as an 8,000 hour problem. For you, it may not be. Check into that. That's not something you want to inherit when you're not aware of it. Pratt & Whitney increases their prices every year, and they have campaigns to help contain the cost of certain upgrades and that type of thing. Pratt increases their prices at the end of the year. If you've got work that's coming due, get it ahead of the price increase. On PT6s, it's 3 to 5 to 6% per year. It could save you a chunk of change. So if indeed there is engine work done, try to schedule it prior to the price increase. If the operator has trend monitoring, that's a plus, and it could tell you what the health of the engine is, what you might be facing, and repairs that might be coming up. It's a good thing. It's a plus for the value of the engine or the airplane. Also, there's things with trend monitoring. Some systems have what's called tattletale boxes. It could tell you if the engine's been over-temped or over-torqued, or the guy has really been sticking the spurs to it, that type of thing. Again, one of those things that most people would tell you it had an event or a hot start or whatever, but some people won't tell you. It's a good, the tattletale boxes, although they're not everybody's friend, for a guy that's purchasing these engines, it's a darn good place to check. Recommend no purchase without adequate investigation. Here's a sample trend monitoring plot. This particular engine is dirty. They do a compressor wash. Everything, you can see the compressor wash there. Everything falls back to where it ought to be. So trend monitoring, very valuable. Again, shows the guy is investing in his engines and is doing the best he can to maintain them well and seek warning when problems might be materializing. Okay, so we've looked at the airframe. We've looked at everything seems good so far. Our gauges are calibrated. we're going to go out and do a ground run on this thing to see if it's performing. If the engine looks good and the performance ain't so great, then perhaps we have an airframe problem, maybe a door seal or a flow pack that's leaking or something that is sucking the power out of that engine and giving a bad indication. It's something that needs to be fixed. You can always blank off the engine and do a performance run if you suspect that there's a problem not engine related, to determine what you might be looking at in terms of repairing something on the airframe that could be causing your trouble. Do a good ground performance run, document it, keep it as part of your records. Fly the airplane. Take that thing up to altitude and see. The numbers are great on the ground, engine should be good. Not necessarily. Get that thing altitude and make sure it is indeed a performer. Take records up there, compare your results ground and in flight, and also see if everything's rigged correctly. Does it come back into reverse? Do the two engines come back together? Are you dancing down the runway? Stuff like that. Very important to figure out. Make sure you're getting good numbers at cruise. Again, might help you to identify an airframe problem. And again, whatever airframe, whatever engines you've purchased, those babies are going to be yours. So now's the time to find out the true personality of the engines you're getting. And you're the key element to that. So there's a little bit about my background. And I've been doing this for a long time. Too ignorant to be retrained. So here I am. Is there any questions or any horror stories or good stories or anything you want to tell? Anything that I can cover that I haven't?
Nothing has come through.
Okay, well, thank you very much. Appreciate you sitting in on this. Hope you enjoy the rest of the show.